Then we're going to move, so we've gone through our first element and our second element. We're going to go to our third element. We're going to note that we have now moved to the second period. We are still in the S block, and we have a total of 2 elements that are in that second period S block, lithium and beryllium. And so we're going to put a 2 here. And now that we've landed on beryllium's spot, we're going to stop, and that is our complete electron configuration for beryllium. Now what this is really telling us is the location of beryllium's electrons. What it's telling us is that 2 of beryllium's 4 electrons are in that first orbital away from the nucleus in an S or sphere-shaped space. And the other 2 electrons that belong to beryllium are in the second orbital, the second shell around beryllium's nucleus, and also in an S or sphere-shaped space. So this is like an address that says exactly where the electrons of beryllium are. So let's try another example. We'll try nitrogen. This one's a little bit bigger. So here's nitrogen. So that's going to be our stopping place. And we're also going to write the symbol. So the mass number of nitrogen is 14. The atomic number is 7. I'm just reading these right off the periodic table. Its symbol is N. And when we go to write the complete electron configuration, we always start at hydrogen, at our first element. And we're going to kind of walk as though this were a board game from hydrogen all the way over to nitrogen in order of atomic number. We're going to make notations along the way. We start in the first period right here, and we are in the S block, and we have 2 elements, hydrogen and helium, that are in that first period S block. So we're going to write a little 2. And that's our first and second element. Our third and fourth elements right here are both in the second period S block. There's 2 of them, lithium and beryllium, so we'll put a 2 here. Then we have to keep going. Our 5th, 6th, and 7th, and remember we're going to stop at our 7th because that's the one we're naming here, writing the electron configuration for. So our 5th, 6th, and 7th atoms are in the second period still, the P block now, and there are 3 of them, right? Boron, carbon, and nitrogen. So we're going to write a 3. And we're going to stop there because this has reached us all the way to nitrogen, whose electron configuration we are naming. Okay, we're going to try another one. And if this seems confusing, you just need to stick with it. It takes a little bit of grittiness here to get used to this. All right, so this one adds a little bit of a level of complexity. Okay, this is about as complicated as we're going to get. And there's some weird numbering that happens here due to quantum mechanics, and I don't expect you to be able to explain why this weird numbering happens, but I just want you to kind of get a little, hopefully, comfortable with it. Okay, so we're going to write the electron configuration of nickel. So here's nickel. And wow, it's really hard for me to read that. I think it says 58.71, so we'd round that mass number to 59. I hope I'm right. And an atomic number of 28. And its symbol is Ni. And even though it's way down there, we're always going to start over at hydrogen. This is like a nightmare board game that you never wanted to play. And so we're going to start off and we're going to say that our first 2 elements here, hydrogen and helium, are in the first period, the S block, and there's 2 of them. And then our third and our fourth elements, remember we're going in order of atomic number, are in the second period, S block, and there's 2 of them. And then all the way over here, going all the way through this time, so we gotta get all the way to nickel, we have still the second period, the P block, 1, 2, 3, 4, 5, 6 elements. We'll go over here to our 11th and 12th elements. They are in the third period, the S block, and there are 2 of them, Na, sodium, and Mg, magnesium. Oh, we're going to keep going. We are in the third period still, the P block, 1, 2, 3, 4, 5, 6. Okay. Now we're down here. So the fourth period, the S block, 2 elements, potassium and calcium. Okay. And now here comes the weird part. Okay. Do you notice that I had you label this as 3? The periods in the D block lag behind. So even though we're calling this the fourth period, and even once we would get back over here, this would all be the fourth period again, this sort of bizarre thing happens right here in the D block, and this is suddenly the third period, not the fourth. And it's not that we forgot how to count, it's that there's some confusing stuff going on with quantum mechanics and sheltering of electrons, and I can explain it to you individually if you'd like, but I don't want to get into the details with everyone because I feel like for some people it's just more than they want to know and it might confuse them. So if you just remember, move this out of the way so you can see this, I have this funny little way of trying to remember this, and maybe it'll work for you. The weird thing is the 4s, remember this was 4s here, comes before 3d. So here's our 3d section. Go figure something 3d would stick out. Get it? 3d is three-dimensional, so it sticks out. Well, here it sticks out because it doesn't follow the rules. Ha, 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 ha. Okay, so at any rate, you got to remember this is the 3D section of the periodic table. And you're going to feel uncomfortable because you're going to think like, what? Did I forget how to count? No, that's how it goes. It's quantum mechanics, okay? And we're going to go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 elements in. And that's nickel, and so we stop. Okay? All right. One more. Stick with me here. On a test or a quiz, we will never ask you to go past element 36 to write an electron configuration. So let's try that one. This is the longest configuration we could ever ask you to write, so we might as well just go for it. So Krypton is over here, and again, I can't read that very well. I hope that's a mass of rounded to 84. Krypton is element 36. Kr. So we start over here, as always. 1s, and there's 2 elements. 2s, and there's 2 elements. Go over here. 2p. 1, 2, 3, 4, 5, 6 elements. Keep moving in order of atomic number. 3s. 2 elements. 3p. 6 elements. 4s. 2 elements. Over here, careful. Move that out of the way. This is now 3D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. And all the way to the end here, because we're going all the way to Krypton, back to 4p. Remember, the 3 is only in the D block section. 1, 2, 3, 4, 5, 6. Whew. That's crazy. That's really long, and you're going to notice that every time you write one of these stupid complete electron configurations, you always end up starting with 1s2, 2s2, 2p6, right? And they always start off the same way. And when you're writing an elements configuration like Krypton that's so big, you end up writing all this long thing. So the next video is going to teach you how you can abbreviate these using what's called noble gas configurations. More on that next.